Greetings and salam to everyone. We are from Team Celestials, and today we are going to present a computer system for cars. And without further ado, this is our team members. For starting, today, automobiles are geared up with a number of actuators and sensors, which are linked to computer systems, guaranteeing the whole lot runs the way in which it ought to. So some of these computer systems embrace the PCM, ECM, ECU, and TCM. Next, I will pass to SHARIFAH SAKINAH to open on the next slide.
So I would like to share about the ECU. ECU is stand for Engine Control Unit, and ECU is the largest category of electronic modules, and it is the brain of an engine. It can handle various performance and drivability function. The function of ECU is to control a series of actuators on an internal combustion engine to ensure optimal engine performance. So how it works? It works by reading values from a multitude of sensors within the engine bay, interpreting the data using multidimensional performance maps, it was called lookup tables, and adjusting the engine actuators. So actually, ECU includes other control systems such as air conditioning, cruise control, airbags, and anti-lock braking system. Next. Okay. So this is the architecture of ECU. As we can see, there is inputs, outputs, comms or interoperability, and the reference data. So as we can see, the inputs such as crank, cam angle, accelerator pedal position, steering angle, coolant or air temperature, mass airflow or manifold pressure, exhaust oxygen, pressure, knob detection, and oil pressure, and OEM CAN bus information. And as we can see, output functions such as fuel injector or pump, glow plug spark ignition coil, turbocharger or throttle position, camshaft position, and alternator or emission valves. Next. Next is the ECU structure for engine control. So as we can see, input will be given from the driver. Then data like steering control, key, pedals, gear, and accessories will pass to driver interpreter. Then it will go to engine control. It will pass to actuator controller, and last, the engine system will react the input to give the output. Next, I will pass to Sarafina Nadia.
Okay, next is the PCM. PCM is the stand for Powertrain Control Module. This PCM is made of ECM plus TCM and is a single more efficient module found in newer vehicles. Other vehicles have an ECM and a TCM. The PCM, also known as Engine Control Module or Electronic Control Unit in the some automobiles. It manages the engine, transmission, other system based on the information it receives from various sensors around the vehicle. Okay, next, how does the PCM works? So first of all, the PCM unit is linked into a variety of sensors through the car, which monitor anything from tire rotation, speed to the engine temperature. So when one of these sensors fail or the PCM generate an error, the driver is usually notified when the check engine light is illuminated. So the PCM works by receiving a signal from a sensor that measures airflow into the engine and out of the exhaust, the coolant temperature, how far the accelerator pedal is, the speed at which each wheel is turning, and others. It then utilizes the data to make the dozen of choice each second, including how much fuel to pump into each cylinder and when to change an automatic gearbox to a new gear to provide the greatest performance for the present condition. So this is the architecture or the block diagram for the PCM. Therefore, from the input, such as the oxygen sensor, coolant temperature sensor, CTS, EGR position sensor, throttle position sensor, TPS, the data will be sent into the microprocessor, or we call it PCM. So the data from the input will be calculated to control this output, such as idle speed control, ISC, idle A control, IAC, injector, canister push solenoid, and EGR solenoid. Next, I will pass to FARISHA.
So the next one is functionality and purpose. The first part is ECU for a full hybrid powertrain structure where ECU able to enhance powertrain efficiency and reduce fuel consumption by utilizing energy management strategy through control function modelization. And also, it will also include logic control modules and coordinate control modules for the first part. Let's move on to the second part, which is the ECU in increased safety, security, and performance of cars, where the number of ECUs often play a role in the advance of the safety, security, and performance of the car, such as in advanced driver assistance system, or we call it as ADAS. So it is one of the example hybrid vehicles in world that already being tested within this time. And then the third one is ECU and PCM in cyber physical security in electric vehicles, where it uses index-based attack input analysis, detection, and diagnosis to fully utilize are important to PCM designers in producing optimal condition of hybrid electrical vehicles. So this is due to the powertrain system in electrical vehicle usually is non-linear and complicated in real-world applications. So in the majority of the controllers in ECUs involve a huge number of engineering experience, phase rules, and lookup tables. So since that, one of the solution is we introduce the established index-based analysis, identification, and diagnose in order to fully use the physical characteristic and performance of the powertrain systems. So now let's move on to the next slide. I'll pass to Clarence.
Next, I will show or discuss the performance similarity analysis. Now, both ECU and PCM are referred to the same subject, which is engine computers. For the second point, that the PCM and ECM will also create signs when it goes unhealthy, where these are most the efficiency points. First is engine won't start. When one of the very important modules goes unhealthy, the engine might not begin. So whenever you start the engine, any faults can cause the system to close down, will be guarded from additional harm. Second is transmission not shifting smoothly. Also, when one of the modules go unhealthy, they will have an effect on the way in which the transmission works. So it might be discovered that one of the things can be obtained is tough shifting and inappropriate shifting occasion. And last is a poor fuel economy. So for optimum gas effectivity, the engine and transmission should run as meant. So whenever a few of the steadiness is off, the gas effectivity can undergo. Next, I will show you or discuss more on the performance comparative analysis. So for the comparatives, so in terms of control, the PCM controls both the engine and transmission system, while the ECU only controls either the engine or transmission system. And as for the usage, PCM are widely commonly used in popular cars model and in automatic transmission car. For example, Hyundai, Kia, or Ford or Honda. And whereas in ECU are usually used in manual transmission cars like Bosch or Toyota. And do not get confused that there are some car brands that uses both PCM and ECU together. As for engine performance for PCM, all sensors send the data to PCM and it responds by making adjustments for optimal engine performances and efficiency. Whereas ECU, it enables optimal engine performance and ideal emission by controlling the air, fuel, and spark. For the last part, this is the main priority, which is the critical operation. For PCM, if any of the involved sensors disagree with the idle speed during this process, the vehicle gets put in limp mode. Whereas in ECU, it alerts the driver to a problem by flashing codes or lights on the dashboard in a timely manner to prevent damage to the car. For critical operation, we will get more in depth by my friend ALIFAH ILYANA.
Okay, constant maintenance is something that we want to avoid. So thanks to PCM and ECU, we can somehow self-diagnose our car problem, whether it's engine or the circuit with less mechanical knowledge. So here we are, share with you guys the faulty symptom that we can observe directly. For example, so for PCM symptom, we can always check whether we have a failure on our engine if we have the check engine light is always on, or the very poor performance and acceleration. And also we can check whether the engine is okay or not, whether we can see the full economy loss for no apparent reason. So moving on to ECU failure symptom. The first one is engine turning off for no reason. Okay, the second one is water or fire damage on the ECU where you can see a spark. And the third one is the car is jump started on a reverse polarity. Next. To take a deeper observation, after visual inspection and battery checking, we can direct plug on the OBD or onboard diagnostic scanner on our vehicle to see whether there is any OBD error coded produced. Now here's some of the faulty code the PCM or ECU OBD produced. So the first PCM code is PO300, represent engine misfiring. The next one is PO171, represent the fuel train trouble. And the last one is PO411, represent evaporative emission control system. As for ECU, we have PO203, represent cylinder 3 injection circuit malfunction. Okay, the next one is P0487, represent the exhaust gas recirculation throttle control circuit is open. And the last one is PO207, represent injector fault or the wiring injector. That's all from us. To deepen our research, we had conducted several meetings and went through numerous resources to present what we have today. This is the first meeting. Next. And this is the second meeting. Okay, to conclude, remember that time we had a weird computer joke whether the cars are controlled by specific computer. Our cars presumably need us to confirm whether we need to brake by clicking yes or no. So now we have come to the era that we cannot live. We cannot even drive a car without a computer. So these computer cars let us drive safely, know which part is broken, and perhaps prevent ourselves from any worse consequences. So with computer cars, we can do all of this. So besides, we all have to admit, without this, no good driving. And all of us know, nothing beats a good driving. That's all from us. Thank you.